Today we're going to map envelopes to a circular motion using what we learned from my last tutorial. We have objects that move around thanks to this algorithm here. So this multi-slider here is generating a point in 3D space, X, Y, and Z. And I am just setting the second cell of this two-cell matrix. And then I am drawing a line from 0, which will be my cell 0, which is left alone with this set cell message, to the point in question. So that's my axis. And what I want to do is create a perpendicular line to that. Then I can rotate around this axis. This is my axis that I normalize, and I just use a cross product to generate a perpendicular vector to my axis. So here I concatenate the axis, which will be a vector of 3, to a rotation value, which will be 1 value. So this will be a vector 4. And then I convert that into a quaternion. You can just use this as your axis to quaternion formula. And then what I want to rotate is actually my vector that is perpendicular to my axis. So if I change my axis, my rotation will always be perpendicular to that. Okay, moving on to the next part of my patch. Here I have a Q metro, which will eventually be my render bang, and this will generate bangs which will be limited to 900 milliseconds. The reason why I also have the fastest Q metro is because I want that to trigger my snapshot as well as output my envelope matrix. I just generate a random number which will trigger a line, but the line will only be triggered on certain channels, one at a time. And then I take a snapshot of the multi-channel of 30 voices, which will output message voice followed by an index. This is actually outputting 30 messages per bang. Then I get rid of the voice symbol, and I set one of the cells of my matrix. You can actually visualize these envelopes with a P window right here. Next, I want to use this envelope matrix to create an accumulation of these envelopes so that the rotation will be continuous, building onto the previous rotation. I'm just using simple accumulation algorithm, the current status of the envelope, which is added to the previous. So another part of the patch is building on that rotation that I was talking about at the beginning. So I'm using the angles matrix, which I built using the envelopes. And that's going to be my rotation value. So I'm using an actual matrix with different values so that the rotations affect different cells of the matrix in a different way. So that's the whole reason why we've been using JitGen, is to eventually achieve this idea of using a matrix to create rotations instead of having parameters that will be a little more cumbersome to manage in real time. So here I have what used to be my param rota in the first examples, And eventually I'm going to add that rotation to my position. So to the position is generated by the JIT-MO part of the patch. Eventually I want to create trails. So I transpose the matrix into a column matrix. I expand the number of columns by using this concatenation and the JIT split, which I talked about in the last video. Okay, the last module of this patch is the one that actually generates the sound, and it takes the information of the different objects to implement a FM synthesis. I need to extract information about the matrix in terms of how big the matrix is, and that's what I have here. And whenever that number changes, I will change the number of channels for my multi-channel objects. So this is my envelope generator, as I explained before. And the random number that is being generated is also dependent on the number of cells in the matrix. And that will create a target message. The Y position is changing the pitch of the sound. So the X value is changing two things. It's changing the modulation of the FM synthesis, and it's changing the panning. My Z value, again with the JIT spill, will influence my depth of modulation.